Pair of linear equations in two variables. An equation of the form ax plus by plus c is equal to 0, where a, b and c belongs to R, where a and b are not equal to 0 and x and y are variables, is called a linear equation in two variables. For example, 3x plus 7y is equal to 9. 2x minus y is equal to 0. When we draw two straight lines in a plane, we may get one of the three possibilities given below. First, when two lines intersect at a point. Second, when two lines are coincident. And the third, when two lines are parallel. Let us see some examples. Example: the sum of two numbers is 6 and first number is 2 more than the second number. Represent this algebraically and graphically. Solution: let the first number be x and the second number be y, given that the sum of two numbers is 6. So we can write x plus y is equal to 6. Also, the first number is 2 more than the second number, so it becomes x is equal to y plus 2. Or we can write it as x minus y is equal to 2. Hence, the system of equations are x plus y is equal to 6 and x minus y is equal to 2. Now, to represent this system graphically, we tabulate a few solutions of each equation as shown. Now, mark these points on a graph paper and join them as shown. And we observe that the two lines intersect at ordered pair 4, 2. Graphical method of solution of a pair of linear equations. The general form of a pair of linear equations in two variables x and y is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where a1, b1, c1 and a2, b2 and c2 are all real numbers and a1 square plus b1 square is not equal to 0 or a2 square plus b2 square is not equal to 0. Let us see some properties of the above equations. If a1 by a2 is not equal to b1 by b2, then the lines are intersecting, and there is exactly one solution that is unique. If a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the lines are coincident and there are infinitely many solutions. If a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, then the lines are parallel and there is no solution. Let us look at an example. Example: draw the graph of the following pair of linear equations. 3x plus 2y is equal to 5 and 2x minus 3y is equal to 7. Solution: to draw the graph of given system of equations, we tabulate the values of x and y. So in equation 3x plus 2y is equal to 5, if we substitute x as 1, then we get the corresponding value of y, which is equal to 1. And similarly, we can get another values. Now we take the second equation, 2x minus 3y is equal to 7. And again we substitute the different value of x and we get the corresponding value of y as shown. Now we plot these points on a graph paper and join them. And we observe that the graph of the given system intersects at a point. So, the system has a unique solution. Algebraic methods of solving a pair of linear equations. Some algebraic methods of solving simultaneous equations in two variables are substitution method, elimination method, and cross multiplication method. Let us understand them one by one. Substitution method. Step 1. Let the equations be a1x plus b1y plus c1 is equal to 0, namely equation 1, and a2x plus b2y plus c2 is equal to 0 is equation number 2. Step 2. Choose one of the equations, say 1, express one of the variables, say y, in terms of the other variable, that is x. Step 3. Substitute the value of y obtained from step 2 in equation 2. Thus we get an equation in one variable, x. Step 4. Solve the equation we got in step 3 and get the value of x. Step 5. Substitute the value of x obtained in step 4 in the expression for y obtained in step 2 to get the value of y. Step 6. The values of x and y obtained in steps 4 and 5 respectively are the solutions of the given system of equations. Let us understand it with the help of an example. Example. Solve the equations x plus y is equal to 14 and x minus y is equal to 4 by the substitution method. Solution. The given system of equation is x plus y is equal to 14, namely equation 1, and x minus y is equal to 4, which is equation number 2. Now from equation 2, we get x is equal to 4 plus y. Let it be equation 3. Now, substituting x is equal to 4 plus y in equation 1, we get 4 plus y is equal to 14. It implies 4 plus 2y is equal to 14, or 2y is equal to 10, or simply y is equal to 5. Now substitute y is equal to 5 in x is equal to 4 plus y, we get x is equal to 4 plus 5 is equal to 9, or simply x is equal to 9. Therefore the solution is x is equal to 9 and y is equal to 5. Elimination method. Step 1. In the two given equations, make the coefficients of one of the variables numerically equal. For this, we multiply the equations by some suitable non-zero constants. Step 2. Add or subtract the equations so that the variable with same coefficient gets eliminated. You get an equation in one variable. Step 3. Solve the equation in one variable and find the value of that variable. Step 4. Substitute the value in one of the given two equations and get the value of other variable. Note: in the step 2, if you do not get an equation in one variable, then you will get either of these. A true statement involving no variable, that is, the given pair of equations has infinitely many solutions. Or a false statement involving no variable, that is, the given pair of equations has no solution. Let us find it with the help of an example. Example. By the method of elimination, solve the given system of equations. 2x plus y is equal to minus 4 and 5x minus 3y is equal to 1. Solution. The equations are 2x plus y is equal to minus 4, let it be equation 1, and 5x minus 3y is equal to 1. Let it be equation 2. Let us eliminate y from the given system of equations. For this, we multiply the equation 1 by 3 and equation 2 by 1, so that the coefficients of y will be equal. Now solving the equations, we get the value of x is equal to minus 1. Now put x is equal to minus 1 in equation 1, we get 2 into minus 1 plus y is equal to minus 4, or y is equal to minus 4 plus 2 is equal to minus 2, or simply y is equal to minus 2. Hence the solution is x is equal to minus 1 and y is equal to minus 2. Cross multiplication method. Step 1. Write the system of equations in the standard form as shown. Step 2. Write the coefficients of x and y and the constant in the following form as shown. Step 3. The arrows between the numbers denote that the numbers are to be multiplied. The products with upward arrows are to be subtracted from product with downward arrows. Step 4. Find x and y provided that a1 b2 is not equal to a2 b1. Let us understand it with the help of an example. Example. Solve 2x plus y is equal to 5 and 3x plus 2y is equal to 8 by cross multiplication method. Solution. First, let us write the given system in the standard form 2x plus y minus 5 is equal to 0 and 3x plus 2y minus 8 is equal to 0. Now represent the variables and constant as shown. Or we can write x divided by minus 8 of minus 10 is equal to y divided by minus 15 of 16 is equal to 1 by 4 minus 3, or x by minus 8 plus 10 is equal to y by minus 15 plus 16 is equal to 1 by 1, or simply x by 2 is equal to y by 1 is equal to 1 by 1. Now equate each variable with constant term and we get x by 2 is equal to 1. It implies x is equal to 2 and y by 1 is equal to 1. It implies y is equal to 1. Hence the solution of given system is x is equal to 2 and y is equal to 1. Equations reducible to a pair of linear equations in two variables. Let us understand it with the help of an example. Example. Solve 3 by x minus 1 by 9 is equal to minus 9 and 2 by x plus 3 by y is equal to 5, where x and y is not equal to 0. Solution. Let 1 by x is equal to u and 1 by y is equal to v and put them in the given equations. We get 3u minus v is equal to minus 9. Let it be equation number 1. And 2u plus 3v is equal to 5. Let it be equation number 2. Let us eliminate v from equations 1 and 2 as shown and get the value of u. So the value of u is equal to minus 2. Now substitute u is equal to minus 2 in equation 1 and we get 3 into minus 2 minus v is equal to minus 9, or minus 6 plus 9 is equal to v, or simply v is equal to 3. As the value of u is equal to minus 2, it implies 1 by x is equal to minus 2, or x is equal to minus 1 by 2. Similarly, as the value of v is equal to 3, it implies 1 by y is equal to 3, or y is equal to 1 by 3. Hence the solution of given system of equation is x is equal to minus 1 by 2 and y is equal to 1 by 3. Elimination method to solve a pair of linear equations. Example. Solve for u and v. U plus 6 by v is equal to 6 and 3u minus 8 by v is equal to 5. Solution. We have two equations u plus 6 by v is equal to 6. Let it be equation number 1. And 3u minus 8 by v is equal to 5. Let it be equation number 2. As we see that v is in the denominator, look at the equation 1. As if we multiply equation 1 by 3u, then we get 3u plus 18 by v is equal to 18. Let it be equation 3. And also we can see 3u is present in both the equations. Now we subtract equation 3 from equation 2 as shown and we see that 3u gets cancelled out. Now we have left is minus 26 by v is equal to minus 13. So v is minus 26 by minus 13 or 2. Now substitute the value of v in equation 1 and we get u plus 6 by 2 is equal to 6 or u plus 3 is equal to 6 or simply u is equal to 3. So now we get the value of u and v as 3 and elimination method to solve a pair of linear equations 2. Example. Solve for m and n. M plus 1 by 2 plus n minus 1 by 3 is equal to 8 and m minus 1 by 3 plus n plus 1 by 2 is equal to 9. Solution. We have two equations m plus 1 by 2 plus n minus 1 by 3 is equal to 8. Let it be equation number 1 and m minus 1 by 3 plus n plus 1 by 2 is equal to 9. Let it be equation number 2. Now first simplify the equation number 1 by cross multiply as shown and we get a new equation 3m plus 2n is equal to 47. Let it be equation number 3. Now look at the second equation and again simplify it by cross multiply and we get the new equation, that is 2m plus 3n is equal to 53. Let it be equation number 4. Now we can see that the equations become easier to solve. Now we first multiply equation 3 by 2 and then we multiply equation number 4 by 3 as shown. Now subtracting the equation 4 from 3, we get 2 into 3m plus 2n minus 3 into 2m minus 3n is equal to 94 minus 159, and after solving it we get minus 5n is equal to minus 65 or simply n is equal to 13. Now substitute the value of n is equal to 13 in equation 3 and we get 3m plus 26 is equal to 47 or 3m is equal to 47 minus 26 is equal to 21 or simply m is equal to 7. So we get the value of m and n as 7 and 13. Graphical solution of a pair of linear equations in two variables. Example. Represent the following pair of equations graphically and write the coordinates of points where the lines intersect at y-axis. S plus 3t is equal to 6 and 2s minus 3t is equal to 12. Solution. We have two equations s plus 3t is equal to 6 and 2s minus 3t is equal to 12. If we want to represent these two equations graphically, then we need to first draw the solution table for each equation. Look at the first equation, s plus 3t is equal to 6. We can rewrite it as s is equal to 6 minus 3t. Now take the different value of t and we get the corresponding value of s as shown. Now look at the equation number 2 and do the same process as we have done with equation 1. So s is equal to 12 plus 3t divided by 2. Now take the different value of t and get the corresponding value of s as shown. We get the solution table for both the equations. Now we first take the solution table and plot the 3 points 6, 0, 3, 1 and 0, 2 and join them and extend the line. So we represent the first equation. Now take the second solution table and again plot the 3 points 6, 0, 3 minus 2 and 0 minus 4 and join them and extend the line. As we see that the points 0, 2 and 0 minus 4 intersect at y-axis and that we required. Possibilities of plotting a pair of linear equations. Consider the general form of two linear equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Now geometrically what happened? both of them represent the straight lines. Now when we have two straight lines, there can be some possibilities. The simplest is shown here, that is, two straight lines intersect each other. The second possibility is that the two lines are parallel to each other. And the third possibility is that the two lines coincide, that is, one line lies on the top of other. Now this presents some interesting facts. Case 1. When they intersect. Look at the point of intersection. This point lies on both the lines, so this point satisfies both the equations. That means this point is the solution to this pair of linear equation. And there is associated condition, that is A1 by A2 is not equal to B1 by B2. So we call it as consistent. Now look at the second case, when the two lines are parallel. Can you think of any point which lies on both the lines? No. That means there is no point which satisfies both the equations. So these pair of linear equation has no solution, and so we call it as inconsistent. And the condition is A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2. Now look at the third case, when two lines coincide. Can you find any point which lies on both the lines? Yes, there are infinitely many points which lie on both the lines. So these pair of linear equations has infinite solution and is called dependent. And the condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2.